So today, we're diving into two ideas that seem like they're from completely different worlds. On one side, you've got this incredible AI that's designed to learn and grow almost like a living thing. And on the other, a wild new theory that says there's a hidden rhythm, a kind of music, buried inside prime numbers. The big question is, what happens when you put them together?
Okay, let's just start with a huge question, right off the bat. What if the most basic patterns of the universe, the secret order that might be hiding in prime numbers, what if that's the key? The perfect blueprint for building a truly smart, evolving AI? I know it sounds a little like science fiction, but stick with me, because the connections here are, well, they're surprisingly mind-blowing.
All right, first up, let's meet the AI. And I gotta tell you, this is not your everyday chatbot. It's a whole different kind of beast, built from the ground up for something much, much bigger.
Yeah, I know, that name is an absolute mouthful, GSAHRVA. But don't get hung up on the acronym. What really matters is the idea behind it. You see, you should think of this less like a computer program and more like a digital organism. It's designed to get smarter by literally rewriting parts of its own code, to evolve. But, and this is the key, it all happens inside a very strict set of safety rules that keep it on the right track. So how does it stay in control? Well, it all comes down to this 5-level structure. You can almost think of it as layers of consciousness. Down at the bottom, the operational layer is the workhorse, just crunching data. Go up a level, and the regulatory layer is like a nervous system, keeping everything stable. Then optimization is all about getting better and faster. But it's these top 2 layers that are really wild. The adaptive layer can actually change the AI's core structure, while the identity layer at the very top is like its conscience, making sure every single change, every evolution lines up with its main goal. It's a system literally designed for responsible self-improvement.
And because of that unique architecture, this AI has some pretty amazing superpowers. It's built to solve some of the biggest headaches in AI right now. For one, it cuts down on hallucinations, making stuff up, by a solid 15%. It has a constant memory, so it can process a never-ending stream of information without ever slowing down. And, crucially, it tackles something called catastrophic forgetting, which means it can learn new things without wiping out the old stuff. But honestly, the most important feature might be the human-in-the-loop control. A real person has to sign off on any major evolutionary change, which is a huge deal for safety.
Okay, let's hit pause on the AI for just a minute. We're going to jump into a totally different universe, the world of pure math. And we're going to look at prime numbers in a way I guarantee you've never seen them before.
Right, so we all learned about prime numbers in school. They're the atoms of mathematics, the numbers you can't divide. And for hundreds of years, the consensus has been that they pop up randomly. There's no real pattern. But what if that's just been wrong this whole time? So here's the radical shift in thinking. Instead of looking at the prime numbers themselves, this new theory looks at these spaces between them. It takes the size of those gaps and treats them like frequencies, like musical notes. And when you do that, when you run a special kind of analysis that's like a mathematical prism, splitting a signal into its pure tones, something incredible happens. The randomness just dissolves. And what's left behind is a beautiful, ordered pattern. The primes start to behave like waves. This quote from the research paper just says it all, doesn't it? The randomness we thought we saw was never really there. It was just hiding a much, much deeper level of order. We just weren't looking at it the right way. And what does this prime music actually show us? Well, you get these stunningly clear harmonic patterns, these spikes that look just like a pure musical chord. You also find what's called scalar recurrence, which is a fancy way of saying it's fractal. The same exact patterns show up whether you're looking at the first few primes or the billionth. And there's a consistent rhythm, a predictable beat to the waves. It's a hidden world of unbelievable structure and elegance.
Okay, now for the really fun part. Let's take that evolving AI from the beginning and this incredible hidden order in prime numbers, and let's smash them together and see what we get. This slide right here, this is the heart of the whole idea. On the one hand, you have the biggest needs for an advanced AI. It needs a better, more structured way to think. It needs a smarter way to evolve. And it desperately needs a way to remember things perfectly. And on the other hand, the properties of these prime waves seem to offer a tailor-made solution for every single one of those problems. It's a harmonic structure, it's infinitely complex, and it's scale invariant. It's almost too perfect. So let's get a little more concrete. Every AI has something called a latent space. The easiest way to think about it is as the AI's imagination, its internal map of concepts. Right now, those spaces are kind of a messy, abstract jumble. So what if we could give that mind a better foundation?
Using this prime field as a blueprint could be a total game changer. You could build the AI's mind on this naturally harmonic structure, making it way more efficient. And here's a wild thought. What if the AI could use that structure to spot its own mistakes? If it generates an idea that doesn't resonate with the underlying prime harmony, it could flag that as a potential hallucination, an unnatural thought. Plus, that fractal nature could help it understand ideas at both a tiny, detailed level and a huge, abstract level all at once. All right, what about memory? This is one of the biggest, most stubborn problems in all of AI. How do you build a machine that can keep learning forever without just writing over its old knowledge? This is where the prime field could become the ultimate memory palace. The GSA HRVA already does this cool thing where it essentially dreams to reinforce its memories. Well, these prime harmonics could give it the perfect template to create richer, more complex dreams, making those memories even stronger. You could even tie the importance of a memory to the loudness of a prime wave, so the most critical knowledge gets the most protection. It is, quite literally, an infinite structure for infinite learning. So where does all this leave us? Is this really what the future of AI could look like? Let's zoom out and look at the big picture. Now, we have to be realistic here. The potential benefits are just massive. We're talking about AI that evolves faster, thinks better, and behaves more safely and predictably. But the challenges are just as big. This would be incredibly hard to compute, and the prime theory itself is still brand new and needs more proof. The connection is, for now, speculative. But you have to admit, it's a deeply compelling speculation. And just remember, we're not talking about some theoretical AI. The GSA HRVA is already a beast. You can see its baseline performance here on some really tough tests. It gets these amazing scores with only 7 million parameters. I mean, that is tiny compared to the big models out there. So the point is, we'd be taking an already incredibly powerful and efficient AI and potentially giving it a fundamental upgrade, using the hidden blueprint of the universe itself. And that leaves us with this one final, tantalizing question. For decades, we've looked to biology, to the human brain, for clues on how to build intelligent machines. But what if the answer wasn't in biology at all? What if it was in pure math? Could the secret to a true, evolving artificial intelligence have been hiding in the music of the primes all along? Look, it might be a long shot, but it also just might be the most exciting idea in AI today.